To understand the concept of header, let us assume that in a given network, the sender with the IP address 141.16.21.32 wanted to communicate a data packet which includes rupees 50,000 transfer to a destination with the IP address 110.119.23 and 43. And this rupees 50,000, which is the main message to be transferred, it is called the data or the payload. And the first work to be done, or first thing that to be done by the sender, is to include the IP address of the destination, which is 110.119.23.43 as a part of the header. This part is called the header. In order to deliver the data to the destination, this packet must have to include this destination IP. Otherwise, the intermediate router will not be able to decide which path to follow. Should it go through this direction? Should it go through this direction? So based on the destination IP address, which is included in the data packet, the intermediate devices or intermediate router decides which path to follow in order to reach the destination. In this case, the size of the data is equals to 100 bytes. Let us suppose that this rupees 50,000 transfer is of size 100 bytes. For example, let us assume. And the size of the header is the destination of the destination IP address, and which is of 32 bytes, considering IPv4. So altogether, it will transmit 132 bytes, and the receiver will receive all the 132 bytes, but out of that only 100 bytes are of useful data. On the other way, we can say out of 132 bits, 32 bits are 2 bytes, 32 bytes are overhead. So this is the overhead ratio, which is almost equal to 24%. Now, suppose that the sender wants to send one acknowledgement by the receiver on receipt of the data. In that case, the sender also have to include its own address, which is the source IP. In this case, 141.1.6.21.32. In the first case, acknowledgement was not required, no acknowledgement. But in the second case, we need acknowledgement. In the second case, total overhead or the size of the header will be 32 multiplied by 2, which is equal to 64 bytes, because 32 bytes are for the destination IP address and 32 bytes are for the source address. Altogether, the size of the data remains same, 100 bytes, and the header size in this case, the second case, the data is 100 bytes as earlier, and the header in this case becomes the 64 bytes. So in that case, it will be around, the overhead will be around 64 bytes divided by 164, and it is approximately equals to 40% overhead. That is, it is higher than that of the previous one. So the second one is reliable, means quality of services. In the second case, QoS in the second case is better compared to the QoS in the first case. But however, in the second case, size of the header or the overhead is more compared to the previous one. So that is why it is said that there is a trade-off between the QoS, quality of services provided by network, and the overhead incurred in the network. Better the better the quality of services, higher the overhead. We cannot achieve better QoS with lesser overhead. That is why it is said that there is a trade-off between QoS and the packet overhead. So in reality, although overhead is not desirable, overhead is not desirable, or the packet header is not desirable, but still we cannot have a proper communication without the inclusion of header in a packet. So every protocol in the network includes a header in front of the actual data to be transmitted, and this header part includes control information. For example, when in this case, when the receiver will receive the data with both the data destination IP and source IP. Destination IP represents the receiver. He knows that it's my packet. But what about the source inclusion of source IP? By looking at the source IP, the destination will come to know. It is implied that the sender needs one acknowledgement. So that's why he will prepare the acknowledgement. He will prepare this data as acknowledgement, and he will put the address of the source, in this case 141.16.2.32, and then it will send it back to the destination or the source from where data was transmitted. That's why if we need better quality of services, we must have to have the more overhead in the network.